We have to understand arrays, how are arrays made, which is declaration, how they are initialized, what are arrays, how do we populate them. The word population is for reading data into an array, means read all the values at all the locations of the array in one go and then searching for the array, and we might have the sorting and all operations. So let's see first thing, what is an array? An array is actually a memory location which is holding not one but many data items. Not one but many data items. So this whole structure is made in one memory location, which is consecutive. It is not scattered. System has then divided this structure into number of boxes, which are called elements, and then system numbered every division of this. Each of the number is called an index or subscript. The first box number or the first box's index or the first element's index is 1 and the last one is 4. The lowest index is called lower bound and the highest index is called upper bound. So unlike a variable, array may hold multiple values. All right, so first difference between a variable and array is that it may hold multiple values. All of the values are of the same data type. When the array is declared, it is made, computer is asked to create an array in computer's memory. Whatever the array that computer makes is of just one data type. Array is found in consecutive memory location. As I just suggested that whenever the array is made, it is made in one memory locations. Few people think that these divisions of the arrays might be scattered in memory, but no, they are not scattered. They are all in consecutive memory locations. Achha. It is static in nature. Static means when the program is being executed. When the program is being executed, during the execution, you cannot change the size of the array. It means if you have got more data to place in array, you are confined by the limit of these elements. You cannot place any more data. And if you have got less data in more places in the array, then that means that you would have to leave these places or elements empty. You cannot change the size of an array during the execution of program. This is called static. There are other data structures like linked lists and binary trees where during the execution of program you can make their sizes bigger or smaller on the go, but over here with the array it is not possible. Then there are two types of arrays. Single dimension array means array where there is just one column, and then two-dimension arrays where we have got more than one columns, means it's not just extending in y direction but it is extending in x direction as well. Means when there is just one column, it is single dimension array, and when there are multiple columns, more than one, it is two-dimensional array. Now, declaration of arrays. Declaration is an act, a command to the computer to create any data structure in computer's memory. So array is a data structure. So let's see how do we create. Now we would have to pay attention to two things. In pseudocode, there is a clear way of declaring the array. in Visual Basic or other languages, there would be different ways doing it. For example, in Python, there is no specific way we can create array. There we use lists as array. So if you want to practice arrays in Python, you would have some trouble because you would have to use list as arrays. List by nature are a bit different than array, but you have to program in a way the array works. So that's why either I will be explaining arrays in pseudocodes or Visual Basic codes, but will be uploading codes in Python, so that those people who are learning in Python would have a clear understanding of it as well. The thing is that these declarations do not mean anything in Python. Python does not have declarations. So in Python, what we do, we write few comments which shows that what is the type of the variable or array and all. Anyways, so declaration in pseudocode. The word declare will be used. Declare, identify means the name of the array. We will use this colon as the word as, and then we would have to write the word array. It's a keyword, then lower bound and upper bound and of data type. Means if we like to create this array whose name is student grade, lower bound is 1, upper bound is 4, and the data type is actually character data type, which may hold just one character at a time. So the declaration would become declare student grade array as an array which starts from the lower bound 1 and ends at lower bound 4 of the data type character. All right, and if we declare the same array in Visual Basic, we would have to pass this command which is called dim, declare in memory. Few people call it dimension, but I believe that the better thing is declare in memory. Student grade, and then in parentheses all we have to do is to tell about the upper bound. The thing is, in Visual Basic, whenever the array is created, it is created from 0 and onwards, means the lowest index or the lower bound is always 0, but we make use of 1 first and we leave 0th index. The thing is that all the pseudocodes in AS level are expecting you to start from 1, whereas in A2 all the lower indexes or the lower bound thing will always be starting from 0. So whatever the question that we are going to solve, whatever the example that we are going to use, we will always be using lower bound 1. So remember, in VB we only show upper bound, but VB when creates an array, it has upper bound plus 1 locations, but we will be only making use of 1 as a lower bound always. So let's go further. First thing is array initialization. Before we go into array initialization, let's revise types and sizes. Data types are integer and real, and every single integer variable or element in array will take 4 bytes. Then we have currency, date or time. They all take 8 bytes. If it is character or boolean, it always takes 1 byte. Then let's say, for example, we are using exam marks array. The name of this array is exam marks. It has got 4 places, 4 elements. So how do we declare this array? Declare exam marks as array starting from 1 as lower bound and ends at 4 as upper bound and of type integer. This is the declaration of this array. Now, how do we assign data to array? Before initialization, this is actually important, that how do we assign data to array? How do we keep data in an array? How do we actually place data in an array? So first thing, let's say I want to place at this location 73. Let's say these are exam marks for one of the students, for one of the subject. So how do we do that? Exam marks and this parenthesis or this large bracket or box bracket tells that we are going to use subscript, means index inside it. So whatever the number that you place inside it will be regarded as the index. So in exam marks array at index 3, we are going to place 73, and there we go. 73 is placed in memory at location 3. Then this is constant. But if we like, we can actually create a variable and then we can use that variable as subscript or index. So here we have created n as a variable, integer variable, and we assigned 4 to it. It means that the value of n is now 4. So exam marks at index 4, we going to place 65.37, and there we go. It is now at this location. Now this I call power of array, which makes it easy for us to use for next loop. Since the lower bound and the upper bound of the array is known, we can always use for next loop. For single dimensional array, a simple for next is good enough. So it will start from 1 and will end at 4. Remember one thing, whatever the question of array that appear in exam will be expecting to perform the whole operation in one go. What does it mean, whole operation? Whole operation means if it is initialization, the whole array from first lower index to upper bound, lower bound, upper bound will be initialized. If the values are being input to the array, means it is being populated, it will be populated from lower bound to upper bound. If it is being searched, it will be searched fully. If it is being sorted, it will be sorted fully. So whatever the operation, initialization, population, searching, sorting, whatever, they all happen from lower bound to upper bound in one go. That's why the best loop, since the lower bound is known and upper bound is known, and same thing is happening with every single element of the array, is for next loop. So let's see. Now, so this 3 is index as constant and this n is variable as constant. All right. Now, a word about initialization. Initialization is actually an act of cleaning up the variables when they are freshly created. What does it mean, freshly created? The thing is that whenever we create variables or arrays, they take up some space in memory. That space might have been taken by another application which was using this location before. So when applications leave memory and operating system regard that memory area where that last application was loaded as free, that space is not cleaned. The application which was closed down on its way out does not clean up the space. It only leaves that space. It's like in a neighborhood, there is a plot, piece of land empty, and there is garbage in it. When the owner of that empty piece of land is selling that plot to someone else, the new person who acquires that, in order to build a home there, they will clean that plot first. So that is how it happens, that the space that we acquire for variables and arrays in the computer's memory, since it had an application earlier, when the application has left, it left all the data belong to that application over there. Only the difference is now that space is available for us to capture. Now when we take that application's space for our variable, the data over there, which is now garbage for us, is assigned automatically to the variable that we are creating. That data is regarded as garbage for our system, so we have to clean it up. So how do we clean? Whenever we create variables of different data types, we clean them with some futile values. Those futile values for any type of numbers, they are integer or real or currency, we initialize them with 0. Means whatever the data is there is cleaned up and 0 is placed there. And then character, we just put double single quote there. Single quote means null, means nothing. Same happens with string, double quotation, null. Boolean is always initialized with false, and date and time, they are never initialized. There is no point making date and time 0. So the thing is that if you require to initialize date and time, so you would initialize it to the current date in current time. Now, for this array, which is exam marks array, we will run this for next loop. As we discussed that for next is the best loop. So this for would go from lower bound to upper bound, from 1 to 4. So in first go of this loop, the index will be 1. So exam marks 1 will become 0. Then next index will become 2. Then this would become 0. So what is happening? When index is 1, element 1, which is exam marks 1, will become 0. When index is 2, in second loop, this location will become 0. When index is 3, this location becomes 0. When index is 4, this location becomes 0. So that is how when this whole loop ends, whole array is initialized to 0. That is what is initialization of single dimension array. Now, array size. The size of the array might be asked in two terms. Number one, how many elements are there? So that is very simple. You're going to count it. 1, 2, 3, 4. There are 4 elements in there. And number two, what is the size of this whole array in bytes? As we have discussed that there are different sizes for different data types. So for the integer, the size is 4. For integer, since this array is made up as integer, so every single element is 1 integer and every single integer is of 4 bytes. So this will be elements, number of elements multiplied by type size. So now there are 4 by 4 will become 16. So it means that this particular array is holding up 16 bytes in computer's memory. That is how we count the size of the array. Now, populate. As I told you that populate means that to take input from lower index to the upper index. From 1 to let's say 4, or in here in this particular example, it is from 1 to 100. We will run a for next loop and we will take one input at a time and we will place that value in subsequent element. So let's see what is actually happening. So let's say we have got an array student names. This student names array, I am actually making it with the connection to pre-release material, task 2, PRM 2020. So I have declared an array by the name student names. Remember, these identifiers should not have a space in it. So this is student names without space as an array which starts from 1, means lower bound is 1 and 200 of string data type. So this loop will work from 1 to 100. In every loop, a single variable will be taken input new student name, and will be placed in ith index of array student name. So when the I is 1, the name that you input will go to index location 1. Then it will ask you again, whatever the name that you put will be placed in 2. In third loop, I will be 3, the name will go to the third element. And this is how it's gonna ask you 100 times about the names of the student, and every student name will be placed in subsequent element of the array. Now, instead of taking a value in the name and then assigning that name to subsequent array location, we can take it directly in the array's location, array's index or element. Means instead of these two lines, I might have put input student names I. But somehow I see in past papers, it is preferred to take input in a variable and then to place it in subsequent array element. But the thing is, it is also possible. But sometimes, especially in O levels and AS level, I see that marks for input and assignment are being assigned in the marking scheme. So it is a good idea to take input in a separate variable and then assign that variable to the subsequent array location. Now, searching an array, as the population goes, the operation is over the complete array, similarly searching. So let's say we have got 100 student names. I want to search a particular name, then I input that name in this variable, name to search. This might be a good identifier, but sometimes it is confusing. So it is name to search. So I input a name, and then this for next loop would go with every single location of the array and finds that name. And if it finds it, then it tells that it is found at this particular array element. This is the most raw form of searching. I'm going to look into it separately because that is again part of task 2.2 for searching, or task 2.1 for searching. So let's see. So we input one value that we need to search in an array if it is found or not. So what exactly happens that X will be considered as an index, and this would go from 1 to 100, and then a value is taken from next subsequent location, which is student name 1 and assigned to n, and then system is matching both. If the value, the name at location 1 is as the value that was input and needs to be searched, if it is there, then an output message is placed that that value is found at X location, and this goes on. Now suppose that in an array there are 100 names and I want to search for a name Mike, and if Mike is placed somewhere, it will be output, and if it is not, there would be nothing on screen. So this type of search, which goes from first element of the array to the last, and in every turn it matches the value with the value needs to be searched, is called linear searching. What do we call it? Linear searching. Linear searching, and sometimes we call it serial searching as well. Now, 2D arrays, though it is not part of the task thing, but we should learn about it because we don't know that when do we have question about two-dimensional array as well. So let's say this is a two-dimensional array. The name is student record. Now there you might see that it's not just one column, but there are 4 columns. So now it would be seen as an array with 3 rows and 4 columns. All right. So these are rows and these are columns. Now, so columns are in this direction and rows are in this direction. Anyways, so you can see that now when we tell that what is the size of array, we first tells about this is actually rows, that there are 3 rows and 4 columns. Remember, whenever we put subscript or indexes for two-dimensional array, the first thing is always a row, and then we have got columns. So first thing is row and second one is column. So how do we tell computer that this is two-dimensional array? By having these 2 values. Remember, in one-dimensional array, it is just one value, 1 to 100. But over here, we have got two values, 1 to 3 and 1 to 4. So first 1 to 3 is number of columns and sorry, rows, and then number of columns. Now, so as soon as we declare student array, system generates this grid of 4 columns and 3 rows. And then when we like to assign, we assign like this, that in second row, third column, place Ahmad. Since it is a string, we have to put the value, the literal, in double quotation. So in second row, third column, Ahmad is placed. All right. Now, as I told you that this is row, this is column, this is row, this is column. How do we initialize the array? Now we cannot use single for next. We have to use two for next, which is nested. Nested for next means for within for. So first we have to tell that from row 1 to 3, and in every row, every column. In every row, every column will be initialized. So system will have first row number 1, and then for row number 1, every column 1, 2, 3, 4. In nested loop, what happens that every inside loop goes on in full for every outside loop. Means for every outer count, there is a complete cycle of inner count. For every outer count, there is a complete cycle for inner count. So for every row, all columns will be initialized. So when the row is 1, column will be repeated from 1 to 4. So row 1, column 1, initialize. Row 1, column 2, initialize. Row 1, column 3, initialize. Row 1, column 4, initialize. And that is how the whole initialization happens with the help of nested loop. So when the row is 1, column would go from 1 to 4. So in first loop, row is 1, and then column goes from 1 to 4. So student record 1 comma 1 will be initialized, then student record 1 comma 2 will be initialized, then student record 1 comma 3 will be initialized, and student record 1 comma 4 will be initialized. And then it gets out, then row changes, number 2, and then the whole thing goes on. So for every row, all columns will be initialized. That is how it works. Now, linear search, let's talk about it in detail. Linear search, since it is topic of PRN, you have to pay attention to it. Now, let's suppose that we have student names array. These two parentheses are describing that this is not a variable name, but an array name. It has got 1 to 99 elements, 99 locations in this array. Obviously, if it is a student name, then it is a string type. So what happened that we have used name to search, a variable in which I'm gonna put that which name I would like to search for in this whole array of 99 locations. So this is single dimensional array. All I need is single for next. Single for next. So from for I, first location lower bound, which is 1, to upper bound, which is 99. This is lower bound. This is upper bound. So that lower bound is being used here, and upper bound. Loop goes on and will check for the value in every single location of this array. Now, this is very simple. If we have found the name, so before loop starts, system will ask you that which name would you like to search for. So you enter the name, that name will be captured in name to search, and then system will look into first index if the name that you want to search for is present at this first index. If it is, then it will output name found at I. If it is not, this condition will not work. Next will send the control back to for. Now I will become 2 and student name 2 will be looked for the value that you have entered. If it is there, it says it is there. Otherwise, it goes on and on and on. And all 1 to 99 array locations will be searched for. Now we need to consider two things. Number one, if we are looking for a value which is an ID or any value that is used to identify someone, something, for example, our national identification numbers, if we are finding those in the whole database or in the whole array, there will be just one number. So let's say if there are 99 students and we are looking for the ID of some student, if that ID is found, now we know that that ID is unique in nature and it will not be found anymore. So if it is found, there is no need to go any further. So let's say if we are finding an ID 1234 and that ID 1234 has been found on location 4. So there is no need to go after 4 to the location 99. So we have to get out. So that is the first type of search, where when we find something and we know that that thing is no more be found, no more, it's no more there, we use what? We use exit for. So if we are sure that one class has got just one student with one name, then there is no need to go any further. But in the case of name, that's not true. A class might have many Mikes, many Zafar, many Alis and all. So this is not a good idea. But if we are looking for something which is actually for identification, then this is a good idea, that you don't have to search anymore. So this exit for command, if in pseudocode and Visual Basic both, kicks out the control of this for next loop. So for next would not go any further. But if you think that let's say for this particular search, if we are searching for the names of students, then we have to actually understand that students might have same name, several students might have same name, so we should not put this exit for. So as many times the name appears, it will be output. Next, this is called flag. Now what is flag? Flag is any variable, mostly a Boolean variable, which at the start of the subroutine or algorithm or pseudocode is made false and checked at the end if the change has brought to this variable, so that we have an idea that if something has happened while the pseudocode was being executed. In this particular case, this is found variable of the type Boolean is initialized at false, and if during the search we have found this particular name which we were looking for, then in this if condition we have made is found true. So let's say the name that you were looking for was not found. The whole array is red. It is not found. So once the for next finished, system will check if is found is still false, then system will output name was not found. If we don't use this flag, what will happen? If the value is found, the system will report, yes, the name was found at ith location, whatever the value of I where it was found, it will be reported. But if it is not found, there is no output at all. So user would always be wondering what happened. So that's why it's a good idea to make use of flag. Flags are always used, they are very important. In exam, marks for flags are always allocated. Mostly I have seen that flags are used with Boolean data type, but they can be used for integer data type, where an integer can be made 0, and if it is something happened during the execution of program, then we make it 1, and then towards the end of the program we look for, if the x is still 0 means nothing has happened, so we could report it, and if it is 1 then we report it as well. So now this is called linear search. So do expect that there might be two things that gonna appear in exam. Number one, whatever that you are looking for, if it is of unique nature, we're gonna use exit for, because if it is found once, it will never be found again. So we don't have to run the whole for next loop. But if it is not of unique nature, that like in this particular case, it's a student name, so there might be several students with the same name, so we are not going to put this exit for inside it. All right, number one. Number two, use of flag. If the name of the student is found, it is being reported, but if the name is not found, not even once, then at the end we should know that if it is found or not, so we should report it. We could report it further. So for that reason we make a switch of flag. The name flag is more popular. We make this flag is found and we initialize it at false, and towards the end we are checking if it is still false, means it is not found. But if it has been found, then in that particular condition where we are looking for it, and if it is there, the name that we are finding, we make first is found true, so that towards the end we have an idea that the value that we were looking for is already found, and we don't have to tell that name was not found. That is how it works, and goes up to 100th index, and the type is integer. So this array will be created, which will be starting from 1 and will be ending at 100, from the lower bound 1 to the upper bound 100. Now, this lower bound and upper bound are called index, and sometimes they are called subscripts, and every location with its index is collectively called one element. So if we want to assign a value to a variable, we just we will just assign the value, which is a literal or constant, to that variable. That is very simple, as we do it in physics, chemistry, maths, and other subjects. But wherever, when we assign a value to the array, we have to tell that at what index we have to put that value. So in that case, we will be using this box brackets, and inside the box bracket we mention the subscript or the index. So that value that we are going to assign to that index will be placed in element number whatever it is mentioned here. So in this case, A3 is 10, so array's third location will be having 10. So now we can use constants as subscripts. Like in here, my array 1 is 9, so my array 1 is 9. My array 4 is 7, my array 4 is now 7. Or we can use variables as an index. So let's have a variable x whose value is 8. So my array x means my array 8 is now 2. So we go and what we see here, 2. Now, sometimes we might have complicated situation, like in here. This is with reference to some past papers, which I observed that inside a subscript, another array was mentioned. Instead of a variable, an array itself was used as, an array's location was used as an index. So that's not the big deal. First, we have to solve what is the subscript itself. So my array 8. So my array 8 is what? 2. So this will be treated as my array 2. So first we solved it, my array 8. My array 8 means it is 2 here. And then that my array 2 will be 30. So my array 2 will be 30 now. So first of all, we need to solve it, find the value out. That value will become the index for the array, and that index, this value will be placed. Assignment. In pseudocode, we use arrow which is pointing towards the left, because in computer science it is always right side being assigned to the left side. If I write 5 is equal to A. So this is a big blunder. Never do that. Because in computer science, it might be correct in mathematics, but in computer science, it is a blunder. You cannot do that. So for this reason, you might have a question which is actually asking you for the explanation that what's wrong with it. So sometimes we are in mathematics mind, so we don't find anything wrong with it, but in computer science, it is always from right to left. So assignment, whenever it is done, it is always from right to left. So whatever the expression should be on the right, whatever the value should be on the right, whatever the value that you take input and you want to assign should be on the right. So this is always a bad idea, mind it. Now, further we go, initialization. So we have this array, we want to initialize it. The simple rule says that if it is an integer, we want to assign a value to every element which is 0. So we have two ways. If we have like these 10, we can write x1 is equal to 0. X is the name of this array. X2 is equal to 0, x3 is equal to 0. But what if it is 100 or 1000 elements in there? We cannot write as many lines. So for that, the best thing is to use for next loop. So for I as an index is equal to 1 to 10, xi is equal to 0. So whatever the value of I in the loop will be assigned to 0, which is the initialization. Then we have got population. Population means that we are going through the whole array and we are taking input and assigning those values in turn to the array. We are filling up the array. So for I is equal to 1 to 10, for this array x, we input a mark and we assign that mark to the ith position. So if I is 1 and the mark is 10, so x1 will become 10 here. In next loop, let's say when I is 2, the mark that entered was 12. So x2, because I is 2, x2 will become 12 here. In the third loop, when I is 3, the mark entered is 15. Then x3, because xi will be assigned this mark, will be 15 over here. All right. So, and I told you that instead of having this input in a separate variable and then assigning that variable to the next subsequent location of array, we might take the input directly to the array new location, our ith location in the loop. But that thing is actually, I have seen in past papers that taking input in a variable and then assigning that variable to the next subsequent location of array is having 2 marks assigned to it, and for this you will only gain 1 mark. Now, searching. With searching, I told you about exit for. If you are looking for something which appears only once, and then you don't have to search anymore because you know that if it is found once, it will never be found again. So you use exit for to get out of the loop for no more searches. And secondly, I told you that if you are looking for something which may reappear like names of the students as it is mentioned in pseudocode, then we actually have to go the whole run of all indexes in the array. That will actually be finding multiple same names which we are trying to find in the whole class. And then secondly, I told you about the flag. We use flag and make it false at the start. Flag is a variable which is of Boolean type, and we make it false. And towards the end, we check it. If it is still false, means that array was not having the name that we were looking for. And if during the execution of the program, if we find that name, we make this flag is found true. That help us to know towards the end of the algorithm that the value was found or not found, so that we could output appropriate errors. Not errors, messages. So let's say that we have got this array from 1 to 5 and it has got names in it. The name of the array is name. Names are Ali, Ahmad, Adil, Zafar, Zen. So first we take input n. Let's say n is Zafar. Now we are looking for Zafar in this array. Zafar is found at 4, but how do we make our algorithm? So flag, I have this time I have made x as integer instead of false. I have made it an integer, so I initialize it at 0, and I have checked it towards the end. If it is still 0, then I have put not found. But if it is made once 1 during the execution of the program, then this message will not be output. So the whole loop goes on from I to for I 1 to 5, and name I, if name I is equal to n, which is Zafar, then it output that found at ith location and will make x is equal to 1, and if it is not found, x will remain 1, and the value not found will be output. Now let's suppose that this array is not from 1 to 5 anymore, rather it is from 1 to 10, and the value that we are looking for, Zafar, is at location 4, then 7, then 9. Now this x is equal to 0, which is a flag. Now when i's location will be 4, it will output found at 4. Found I means found 4. Then it will go on, and at when I the location, the number, the loop, the ith position will be 7, it will again say found 7. And when ith location will be 9, then it will say that found at 9. All right, so be careful. So when we are looking for the search which is unique, we, as soon as we find, we put exit for. But as in this case, here we have same name appearing several times. We don't have to put this exit for there. All right. So that is the fundamental